Hi everyone, welcome back to another video on the channel. In this video, we are going to solve another problem in our DSA series, that is check Pythagorean triplet. So let's introduce the problem and discuss the approach by which we can solve the problem. So what is a Pythagorean triplet? I think everyone must have studied this in the school, that is what is Pythagorean triplet. So let me check the images in the Google so that I can explain the concept of Pythagorean triplet just to revise the concept again. So Pythagorean triplets are nothing but the length of the sides of a right angle triangle. As you know, if we have to find the hypotenuse in the right hand or right angle triangle, we need to do this particular thing. That is a square plus b square is equal to c square. That is base square plus height square is equal to hypotenuse square. So that is nothing but our Pythagorean triplet. The three numbers that combine to satisfy this equation a square plus b square is equal to c square. So the triplet of a, b, and c are Pythagorean triplets. So let's go back into our problem and see how can we solve this using our coding logic. So in this problem, maybe you have been given a set of three numbers. Maybe you have been given an array, and you have to find that a Pythagorean triplet exists in the array or not. Or if you are given a set of three numbers, then you might have to check that the three given numbers is a Pythagorean triplet or not. So in this my notes part, we will check that we have been given a set of three numbers, and we will see that how can we check if it is a Pythagorean triplet or not. So in order to check the Pythagorean triplet, we need to satisfy this formula, right? A square plus b square is equal to c square. But what will be our c square? Our c square will be the length of the largest side, that is the hypotenuse. And a square and b square are the, or a or b are the remaining two sides. So first our job is to find the max value or the hypotenuse. So let me initialize the max value as a, or the first of the three set number. Then we use the if else ladder to find the greatest number among three numbers. So in case the b is greater than the original max, that is the first number, we assign the max value to b, or we assign b value to max. Or if c is greater than max, or c is greater than a and b, we assign the c value to the max. So I think this will be extremely easy to understand. There will be no issues. So the next part of the logic lies in the flag conditions, or we have to check that the given set of three integers are satisfying the given condition of a square plus b square is equal to c square or not. So here also we have to use if else ladder. So if our max value is a, that means a is our hypotenuse, remaining b and c are the rest two sides. So we take a boolean flag variable which will basically store the value of this. This is nothing but we are checking that b square plus c square is equal to a square or not, because a is the hypotenuse. So that's why we have to check the square of the remaining sides and their sum is equal to the square of third side or not. Similarly, we do the same for b, for when max is equal to b, or when hypotenuse is equal to b, and when hypotenuse is equal to c. So according to that, this condition will vary. So when a is the hypotenuse, we have to compare the square of the remaining two sides with a square. Similarly, when b is the hypotenuse, we have to compare the squares of the remaining two sides with the b square, and similarly in the case of c square. At last, we have to print the flag. That means if any of the cases are satisfied, that means a our number is a Pythagorean triplet, or the given set of three integers is a Pythagorean triplet. Because as you can see here, 3 square plus 4 square plus 5 square, 3 square plus 4 square is equal to 5 square. But in this case, we are checking that all the possible scenarios of the triplet. That means we are also checking 4 square plus 5 square is equal to 3 square or not, or 5 square plus 4 square is equal to 3 square or not. But that is obviously wrong. So only one case where our condition gets passed is when 3 square plus 4 square gets compared with the fifth, or the number 5 square. Getting my point? So this if else ladder basically checks all possible combinations for a triplet because 345 is also a Pythagorean triplet, 435 is also a Pythagorean triplet, and 534 is also a Pythagorean triplet. So these are basically variations or different permutations of our Pythagorean triplet. And if any case our Boolean flag value gets assigned as true, that means it will break out from this if else ladder, and just we have to print the flag variable. If at any case the flag value is true, the answer will be returned as true. Otherwise, the default value of Boolean value in Java is false, so the false value will be returned. So now let's move into the code editor and code out the problem. So this is the problem on gigs for gigs, where we have to find the Pythagorean triplet in the array, which is little bit different from the one we saw in the notes. So, but the logic is same. We have to compare the hypotenuse square with the sum of square of the remaining two number. So we have been given an array that contains of some integer, and in case there is some Pythagorean triplet exists in the array, we have to return true. So as you can see in this array, 3, 2, 4, 6, 5, 3, 4, 5 is obviously a Pythagorean triplet. So in this case, we have to return true. And in this case, as you can see, 3, 8, 5 is not a Pythagorean triplet. So we return false value. So what will be our approach? We cannot possibly check all the combinations of the elements in the array because that will be too many conditions to check. Getting my point? Because there are five elements in the point in the array. So if we take combinations of three, we have to check for many different combinations. Similarly, the given array size can be 10 to the power 5. So imagine the number of combinations that we have to check if we take all possible cases. So we cannot do that. So what can we do? Instead of taking all three numbers and comparing them, we can do something like this. Let me uh, write the approach of our problem that we are going to solve. Our solution approach, I'm writing down in this comment. So what we have to do? First thing, we have to store the array elements inside a hash map or inside a hash set. Inside a hash set. As you know, hash set only takes unique numbers as the input. So in case of any duplicacy, it will just reject the number. So we store the elements in the hash set. Now we take combination of two. Now we take combination of two numbers. Combination of two numbers. Like we can check 3, 2, and we have to check that 3 square plus 2 square is 9 plus 4, 13. We have to check if square root of 13 exists in the array or not. And where can we get that if it exists in the array or not? This hash set will do the job for us because we have already stored the elements inside a hash set. So in case we have to check that that particular number exists in the array or not, we can refer to the hash set. Now we take combination of twos and check if the first number a square, and the second number b square is equal to c square, obviously. So this will be our sum of two combinations. So this. Let me give this as a variable sum. So now we have to check that is there any element that has the square root of this particular value. Check if any element c exists such that c is equal to square root of sum, because that's basically a Pythagorean triplet, right? We have to check that 3 and 4 we have square term, 3 square and 4 square, and we have to check that the sum of the square of the remaining two numbers, whether their square root exists in the array or not. Getting my point? We are doing basically this. We are getting this sum and checking that is there such a number such that the square of that number is equal to the our sum. So let me simplify this a little bit for you. Uh, Check if any element c exists such that c square is equal to sum. Getting my point? So C square is basically A square, or sorry, sum is basically A square plus B square. And how can we do that? We can check from hash set. In any case, if we find it to be correct or if it exists, return true, otherwise return false. So if exists, return true, otherwise false. Getting my point? So let me just code it down so that you can understand it better. Don't worry. If we when we move to the coding, it will be clearing up. The things will get cleared up, and I will explain this approach again once we code out the thing. So the first step is step one: store array elements in a hash set. So let me declare a hash set, new hash set. So hash set is basically a collection entity of Java which stores the unique element. So let me use a for each loop over here and push the elements into the hash set object. So our hash set object is ready. Now we have to take combination of two. How can we do that? We can do that by using do for loop. The first number as ARR of I, and we take the second number as ARR of J. So we basically got our two numbers. So let me declare a sum, and sum value is nothing but A square plus B square. Getting my point? So we have to check that this C element exists or not. This C element exists or not such that C square is equal to our sum. So let me write the condition. If uh, let me initialize this C as something like this, math dot square root of sum, because our C will be nothing but the square root of this sum. A square plus B square is equal to C square. So C square or the number C will be is equal to the root over of A square plus B square. That is root over of square root of sum. So if C square is equal to A square plus B square, and it exists in the array, and all our array elements is inside the hash set. So we have to use this condition that the hash set contains C. That means our C element that satisfies this condition is existing, and which is confirmed by this hash set that this condition is satisfied and the element is also existing. So at that point, return true. Think nothing else but return true. Otherwise, the loop will carry on. And if till the end we did not hit this if condition, that means our condition is not satisfied and no value is returned till now, and all the permutations of and all the combination of I and j are exhausted. So at that point, we have to return false. So getting my point? So let me explain you the approach again. So in the first step, we store the array elements inside a hash set. In the second step, we took all the combination of uh, two numbers, take combination of two numbers, and inside that check that if any element C exists such that C square is equal to sum. So obviously C will be equal to square root of sum. So we check that if any element existing in the hash set object which contains the array elements such that this condition or our Pythagorean condition is being satisfied. At that moment, we are returning true. Otherwise, the value will be returned as false. So let me hit the compile button and it's running. So, oh, sorry, we have to typecast it to the integer value so that it will be assigned to the C variable, which is integer type, because math dot square root function returns the value in double format. So as you can see, the sample test cases have been passed. So let me hit this submit button, and it is processing the test cases. And as you can see, all the test cases have been passed successfully. So that's it for this video. I hope you liked this video and understood what I was trying to explain. If you have any doubts, you can definitely reach me in the comments. I will be happy to answer your doubts and clear any queries. So happy learning, and till the next video, keep learning.